am just reading all about volcanoes. This is a great little book. Come take a look. This really is an awesome little book full of so much information about volcanoes. The pictures are great. Although, on camera, this book is really hard to see because it's so tiny. So, let's make it bigger. Are you ready? Alright, now that we got a nice big volcano book, let's learn about volcanoes. So, here I have just a regular volcano. And I'm going to put in some baking soda. Whoop. Put in a little too much. There we go. Now that I got some baking soda, I have vinegar, and I just put in some red food coloring. Let's watch our volcano erupt. Wow, look at that eruption! Volcanoes are so fascinating. Wow. You can find out so much amazing information in a volcano book. Listen to this. An island is born. What happens when two plates of the earth, so ground, pull apart? They make a giant crack in the earth. Magma can rise up through these cracks. This even happens underwater. Underwater? You mean there are volcanoes underwater? I wonder. Let's try to make an underwater volcano. For this experiment, you're going to need some cold water. I took this water right out of the fridge. You're going to need a clear jar. I'm using a mason jar because it's glass and it's nice and big. You're also going to need a smaller clear jar that fits inside your big jar. So I'm using a baby food container. You're going to need a rock or something to weigh down the small jar. I'm using a magnet from Learning Resources Sink or Float set because it'll be just enough weight to weigh it down. You also need hot water, food coloring, something to stir your food coloring in your hot water, a spoon, a science stick, popsicle stick. You're also going to need a funnel. And I always like to have a tray because science is messy. Alright, we have our mason jar. We're going to put our cold water in it. Not all the way full, about maybe 3/4 of the way. Set it aside. We have our hot water. I put in some red food coloring and stirred it up. You're going to want to get your jar. Put in a rock or something to weigh it down. I'm using a magnet from the Learning Resources Sink or Float activity. This is just to weigh it down so it doesn't float up. You're going to pour your hot water in the jar. So we got our hot water, we have our cold water. Before we can do the experiment, we need to do our recording sheet because a scientist must always make a prediction and then record their observation. So, my science experiment on underwater volcanoes. My prediction. So we're going to have our big jar. And I always start my drawings in pencil so I can erase it, just in case I make a mistake. Then we're going to have our little jar inside. That looks good. Now I can do a black crayon to make my drawings pop, because we always want our drawings to pop. Look how much awesome that looks when you put the crayon in it. And our little jar has our red food coloring. Now when we put the little jar of red food coloring and hot water inside the big jar of cold water, what do you think will happen? I think, because I know it's an underwater volcano is the name of our experiment, I think the color will come out. What do you think will happen? Let's get to the experiment. Now that we made our prediction, let's see what'll happen. We're going to take our hot water, we're going to put it inside of our cold water. Let's watch it again in slow motion this time. Make sure you look at the inside of the jar. You can see the water from the red bottle, from the red container, moving upwards. Before we can find out the why this happened, let's record our observation. So, initially, my observation was almost correct, but instead of the color shooting out, it kind of flowed out all together. So there's my two containers. And then the red with the hot water kind of went off in little splurts and then made the whole thing red. Kind of like a cloud of red, and it filled in all the cold water. What an amazing experiment, but I still don't understand how it worked, and how does an underwater volcano really happen? You know what we need? Our question book. It has all the answers. Alright, question book. Here's my question. Why did our experiment happen like that? Why did the hot water slowly trickle up into the cold water? And how does that relate to an underwater volcano? How does it work and why it happened? Hot water rises to the top because the molecules in it move faster and therefore make it expand and become less dense, causing it to rise. We learned this last week. Now it's starting to make sense. But how does a volcano erupt? And how does our experiment resemble a volcano? Why does a regular volcano erupt? Volcanoes erupt in different ways. Volcanoes erupt when molten rock called magma, that's the hot liquidy stuff, rises to the surface. Magma is formed when Earth's mantle melts. So when the inside of the Earth starts to melt, it creates liquid called lava or magma. Melting may happen where tectonic plates are pulling apart or where one plate is pushed down on another. So the tectonic plate is like the ground, and when it's shifting and moving like it does all over time, sometimes it creates a gap. And when a gap forms, sometimes it can push up to form a mountain. And if the mountain has a crack all the way down to the bottom, it can reach the magma. Magma goes up the mountain, and when it hits the surface, it explodes, creating hot lava. Magma is lighter than rock, so rises towards the Earth's surface. As the magma rises, bubbles of gas form inside it. Running magma erupts through openings or vents in the Earth's crust before flowing onto its surface as lava. If magma is thick, gas bubbles cannot easily escape and pressure builds up as the magma rises. When the pressure is too much, an explosive eruption can happen, which can be dangerous and destructive. But that's a regular volcano. How do we get underwater volcanoes? The volcanic ocean floor. Did you ever see a round fishbowl made of smooth glass? The ocean is like an enormous fishbowl, but the ocean floor is not smooth. If you were to drain out all the water, you'd find mountains, and many of those mountains would be volcanoes. Underwater volcanic eruptions are caused by the seafloor ripping itself open to let magma through. So, just like a volcano on land, in the water, on the ground, the ocean floor, parts of the earth can be ripped open, creating a crack. And if the crack goes right down to the magma, it can rise up and explode, even though it's underwater. As plates on the ocean floor shift, the molten rock pushes up through the crack, cools, and solidifies into new rock. This helps to build up the mid-ocean ridges. So a lot of the stuff in the ocean, the ridges, are built up from volcanoes underwater that explode. They're also called submarine volcanoes. So an underwater volcano is just like a land volcano, but it happens underwater. How does that relate to our science experiment? Well, our cold water is like the ocean. Our glass of hot water is the beginning of the crack in the ocean floor that went all the way down to the magma. And when it goes in the cold water, that is like when the crack opens up and starts to get pressure from the bottom, and it rises up, and then the lava goes all into the ocean. Except for, because we use water and not real magma or lava, we weren't able to see how when a magma cools in the ocean, it becomes a solidified rock. Volcanoes are pretty amazing. You know, I kind of want to learn more about them. I think I need my Volcano Book. I think I need my Volcano Book.